everyone, and good day to my grade students. Hello, I am your teacher, Rosalyn Abapo, and for today's lesson, we're going to tackle all about the particle nature of matter. You will be familiarized with these terms: the matter, particles, molecules, and atom. This module about particle nature of matter will shift your understanding about microscopic view of materials, and your understanding of the particle nature of matter is crucial in how you will understand what is thought in the life, physical, and earth sciences. And this topic aids you to explain the concept of how matter is made of. So in this video, we will talk about the properties of solid, liquid, and gases based on the particle nature of matter. So now let's get started. So when you compare a pencil, a laptop, and a smartphone, surely you will say that the laptop is the heaviest of the three objects, while the pencil seems to be the lightest. On the other hand, the smartphone may not be as heavy as the laptop, but it is not as light as a pencil. So what does this indicate? It means that all things around us may be light or heavy. Simply put, that these things have mass. Mass is a measure of the amount of matter an object has. The object in the pictures show that they occupy space. Volume is a measure of the space occupied by an object. So, what do we call this object that have mass and volume? We call them a matter. How about air inside a balloon? Does it have mass? Does it occupy space? So the air inside the balloon occupies space that we are able to inflate balloons. They also add mass to balloons. Hence, the air inside balloons are considered as matter. How about heat and light? Do they have mass? Do they occupy space? So heat is energy in transit and light is a form of energy. They do not have mass and they do not occupy space, so they are not considered as a matter. Variety in matter can be traced to the nature of the particles composing them. One example of matter noted for its variety physical form is water. Water is a common substance that we encounter. The icebergs, water in the ocean, and the vapor in the sky are all considered water, but they are of different states. Alright, let's do a quick activity. So here are the procedure. First, fill a cylindrical glass bottle with the water up to 10 ml mark. The bottle has line markings for the 10 ml and the 16 ml. The lower line marking is the 10 ml while the 16 ml mark is the highest. Add 5 1/4 teaspoonfuls of sugar in the bottle. Mix or shake it thoroughly until all sugar is dissolved. The question is, what is the volume of the sugar and the water mixture, and what should be the total volume of the solution? Now let's recall the volumes in our experiment. We poured 10 ml water in cylindrical glass bottle. We added 1/4 teaspoon of sugar to the cylindrical glass bottle 5 times. Note that 1/4 teaspoon is equivalent to 1.2 ml. So therefore, 1.2 ml times 5 equals 6 ml of sugar. So the total volume inside the cylindrical glass bottle must be 10 ml of water plus 6 ml of sugar equals 16 ml. You have observed that the resulting volume is less than 16 ml. And why is this so? Water is made up of tiny particles called molecules, with the spaces between them. Sugar also made up of molecules. Water molecules could fit in the spaces between the sugar molecules or vice versa. For an example, If you pour 1 cup of tap water into a transparent glass and add 1 small drop of food coloring slowly, and then after 1 day, what do you think will happen to the food color, and what is your hypothesis about this? So this time you observe that the food coloring is evenly scattered out of the water. And then the question is, who figured out that all matter is composed of tiny particles? So it was the Greek philosophers named Leucippus and Democritus around 50th BC who had an idea that all matter consists of small uncuttable particles called atoms, and later on came to be known as atoms. So all of matter is made up of tiny particles that are in constant random motion. So scientists call these characteristics as a particulate nature of matter. After more than 2,000 years, the ancient philosophers' idea about atoms became a theory. So atoms became a theory when John Dalton put together many observations and results of several experiments done by other scientists and formulated the atomic theory. Earlier, scientists attempted to explain the composition and behavior of matter through the molecular theory of matter. And this theory has the following assumptions. Number 1, all matter is made up of tiny particles called molecules. Number 2, there are spaces between molecules. Number 3, molecules are constantly moving. And lastly, number 4, molecules are attract one another. So this theory was later on improved through the course of time and named as kinetic molecular theory of matter. Molecule is a particle consisting of 2 or more atoms combined in a specific arrangement. It is an electrically neutral particle, and it is the smallest particle of an element or a compound that can exist independently. And for example, molecule of water consists of an oxygen and atom combined with 2 hydrogen atoms. And also, atoms of the same element can also combine to form a new particle. For instance, oxygen in the air consists of oxygen molecules which are made up of 2 oxygen atoms. So going back to our previous example, we said that the icebergs, ocean water, and vapor in the sky are all water. And the question is, why don't they look very different from each other? So this observe the differences in water or originates from the nature of water particles. The particle theory of matter describes the phases of matter at the microscopic level, and it also explains the differences in the properties of solids, liquids, and gases. Moreover, the theory also explains the changes of phases of matter. Solid, we have iceberg. Its particles are packed closely together and vibrate a little in a place, but in a fixed position. Icebergs are considered as solid because its particles are held together by strong forces. Solids have different shape and volume. They are incompressible. So why does a solid behave differently from a liquid or gas? This question can be answered using the concept of molecular structure of solids, liquids, and gases. So now let's take a look in gas. Let's take, for example, air inside a balloon. The particles of air inside a balloon are constant in motion and are far apart from each other. They are considered as gas since their particles can move to any spaces available when you inflate or deflate a balloon. It, its shapes changes because it is a gas. Gas is a state of matter that has no definite shape or volume. The particles of a gas move very quick and fast, so they can break away completely from one another. There is a low attraction between particles of a gas and between particles of the same element in the solid or liquid. How about liquid? Well, the particles of water are closer to one another than to gas particles, and they are in constant motion. Water in a glass is considered as liquid. Liquid particles move fast enough to overcome some of the attraction between them. The attraction between their particles are stronger than those in gases. Liquids do not have definite shape, just like gases, but they take shape of their container. Liquid, the particles slide past one another but stay together. So liquid have unique characters. A special property of liquids is surface tension. Surface tension is a force that acts on the particles at the surface. Surface tension causes some liquids to form spherical drops like the beads of water. So now, let's wrap things up. Matter is made up of tiny particles called atoms. Atoms are the smallest particle of matter. Molecules are atoms bonded together. The states of matter are physical forms in which a substance can exist. Shape is the external form or appearance of an object. Volume is the measure of how much space an object takes up. Surface tension is a force that acts on the particles at the surface of a liquid. Let's have summary about solid, liquid, and gas. In solid, it retains a fixed volume and shape, while liquid follows the shape of the container which it occupies, and also gas follows the shape and volume of its container. Meanwhile, the solid particles are locked into place. Liquid particles can slide past one another, and gas, the particles can move fast between one another. In solid and liquid, both are not compressible. However, the gas is compressible. Solid is unnoticeable space between particles, while liquid is a little free space between particles, and gas, lots of free space between particles. Solid does not flow, while liquid and gas flows easily. So this is the end of the discussion. I hope you learned something. Thank you for listening and stay tuned, class.